Section 4.5, completing the square. This is our fourth method of solving quadratics. So far, we have solved by graphing, we have solved by factoring, and we have solved by the quadratic formula. Solving by graphing is probably the least useful, unless we have a graphing calculator that gives us exact answers. Factoring can be the fastest, but not everything is factorable. And then quadratic formula and completing the square will always give us exact answers. So those will be our two go-to methods when we're solving quadratic equations. So in order to understand completing the square, we need to understand what perfect square trinomials are, because those are going to be the way to solving by completing the square successfully. So recall a perfect square trinomial is when we clearly have three terms for a trinomial. The first terms are perfect squares, and the second are twice the product of the square roots. Now, we could either have a scenario where there's a plus sign first or a minus sign first. We will always have plus signs at the end because in order for something to be a perfect square, it must be positive. Now, when it's a plus sign, it just means my factorization has a plus in it. When it's a minus sign, it means my factorization is subtraction. So let's clarify with an example what it means to be a perfect square trinomial, and then let's factor that completely. So I'm going to check by saying, is the first a perfect square? Yes. The square root is 5x. Is the second a perfect square? Yes. The square root is 2. Now, is twice 5x times 2 equaling that middle term of 20? That's what we have to determine. So if we do that out, we have 4 times 5x, which is 20x. And I apologize, I forgot the x over here. So they do equal each other. So we know that, yes, this is a perfect square trinomial. Now, what is the factorization? So the factorization is pretty much using the values we just checked. So we take the square root of the first term, which is 5x, and the square root of 4, which is 2, and we put them in parentheses, all squared, and the sign is just based upon that first sign, which is a plus. So the factorization is the quantity of 5x plus 2 all squared. Okay, so when we are solving with completing the square, our goal is to create one of these perfect square trinomials. So in our next example for parts A and B, we have a trinomial, but we need to figure out that third term to make it a perfect square. So to do that, we're going to kind of undo what we just did. So what we have to do is, instead of taking square roots and doubling, we're going to undo that. We are going to take half of the b value and then square it. So instead of doubling, we're going opposite. So we're taking half, and instead of square rooting, we are squaring. So in this case, half of -3 is -3 halves. And then we square that, which gives me 9/4. So C equals 9/4. You try B. Take half of the B value and square it. Okay, now we're going to look at solving with the square root property. This is where we sort of already have half of our work done, and then now we can finish solving. So when we go to look at completing the square, none of the work will be done, and we have to do all of our computations and solve. With solving with the square root property, we sort of have half of the work done for us. And that is that we have a perfect square on one side of my equal sign. So in our first example, very straightforward. I can just add 7 to isolate the variable. And now I take our square root, and remember, when we take square roots, we need the plus or minus. So very straightforward with A, using the square root property. With B, it's not so simple, right? I could subtract 81, but then I still have x's on both sides. However, the good news is This left-hand side is an entire perfect square. It's a perfect square trinomial. So I'm going to factor that, right? The square root of x squared is x. The square root of 81 is 9. Twice 9x is 18x. So we have a perfect square trinomial. I will factor that. That will become x minus 9 all squared, the minus sign from the subtraction, equals 49. Now that I'm at this point, we can simply take the square roots of both sides. I have x minus 9 equals plus or minus 7. Again, don't forget the plus or minus 7. At this point now, we will add 9. So I get x equals 9 plus or minus 7. Remember, that's going to actually give us two answers, and I'll put them in a solution set. From least to greatest, we'll either have 9 minus 7, which is 2, or 9 plus 7, which is 16. And there are my solutions. You try C. Okay, let's put all of this together, and we're going to start from where we have any old trinomial now, okay, or it could be a binomial, but where we have a quadratic equation that is not necessarily factorable. It's not already a perfect square. So what we're going to do is create a perfect square trinomial and solve by completing that square. So if we look here, this is not a perfect square trinomial already. We have two perfect squares, but twice their product, right? This would give us an x and a 2. Twice their product is 4x. So this is not factorable. So what we need to do is complete the square. This 4 is not helping us. So what we're going to do is move it to the other side. I'm going to leave some space and create a new c value. Now, one thing you have to check, and you can look at the steps, is of course, first I move that constant, but then you need to make sure that leading coefficient is a 1. The good news is it is. So now I'm going to create a perfect square trinomial over here, just like I did in parts A and B of example 2, figuring out what that c value should be. So in step 3, I'm going to take half of B and square it. So half of 6 is 3, and then 3 squared gives us 9. So I'm going to take that 9 and put it on that left-hand side. Now I have a perfect square trinomial. However, if I do something to one side, I must do it to the other. Once I have my perfect square trinomial, I can now factor, right? At the very beginning, we weren't factorable, but now I am. So the square root of x squared is x. The square root of 9 is 3. Twice 3x is 6x. So this becomes x plus 3 all squared, right? Positive sign from the positive up above. Equals, on the right-hand side, negative 4 plus 9 is 5. Now that I have this perfect square trinomial that I have factored, I can continue solving by using the square root property. So I'll take the square root, and I get x plus 3, that whole quantity, equals plus or minus root 5. Lastly, I will subtract 3, and I have two solutions here. X equals negative 3 plus root 5, and x equals negative 3 minus root 5. Let's try one more together. So for B, again, I need to move my constant over. I now have 3x squared minus 11x equals 4. However, this time we have this coefficient. So I need to divide through so that I have my coefficient being a 1. That's step 2. X squared minus 11 thirds x, leave some space, equals 4 thirds. Now I'm going to complete the square to create that perfect square trinomial. So I'm going to take half of the b value and then square that. That gives me 121 over 36. I will add that to both sides. Now that I've created a perfect square trinomial, I can factor. So that left-hand side, square root of x squared is x. The square root of 121 over 36 is 11/6. This will now factor to be x minus, because of my subtraction sign, x minus 11/6 all squared equals, and we need to clean up that right-hand side. So if I want to make that 3 become a 36 for a common denominator, I multiply it by 12, so 4 times 12 is 48. Now I combine 48 and 121, and I like the looks of that. I still have a fraction, but I get 169 over 36, which are both perfect squares. So it's going to make the next step of using the square root property really nice. We get x minus 11/6 equals 13 over 6. Now we will add 11/6 to both sides, and I apologize, plus or minus, of course. Plus or minus 13/6, and then we clean those up. So one solution is 11/6 plus 13 over 6, and one solution is 11/6 minus 13 over 6. From least to greatest, that's going to give me two solutions. 11 minus 13/6 is negative 2/6, which is negative 1/3. And our other solution is 24/6, which is 4. And there are my two solutions. Okay, please use completing the square to try part C. You can always then use the quadratic formula to double check your answer, but solve by completing the square.